Now it is clear that the capacitance of a single conductor is very small. We took Earth as a conductor, so the capacitance came out to be 711 microfarad. This is very small quantity. Now we have, if we want to enhance the capacitance, electrical capacitance, so we have to do something else than the single conductor. So what we do, we make a device called capacitor. So a capacitor is nothing but an assembly of two identical conductors separated by a distance. So let us take two identical conductors as two sheets, identical sheets, and they are separated by a distance. Area of each sheet is A. Now the two are given sigma and minus sigma, equal charges. And how it is given? The equal charges are given to this. This is by method of induction. Now you know that if there is a positive charge, then what happens? The electrons are attracted towards the plate number 1, and there becomes a deficiency of electron on the other side of this plate 2. So now if we connect the plate 2 to earth, to ground, this is earth. If we earth second plate, what happens? The electron from the earth move toward the second plate and neutralize these positive charges, and this becomes negatively charged. Second plate becomes negatively charged. Now if we remove earthing, so what happens? We get two sheets with equal and opposite charge densities. If we remove this earthing, then we get two plates with equal charge densities but of opposite nature. So now recall, we have in the earlier video seen that electric field outside this plate 1 and outside the plate 2 is 0. Now recall this one. We calculated here electric field. Here electric field is 0. Here electric field is again 0. But in between the two plates there is electric field, and the value comes out to be sigma upon epsilon. So the field points in between these two plates from positive plate to negative plate, and the value of this electric field which exists between the plate is sigma upon epsilon naught, and it is uniform because it is not depending on, independent of R, not depending on R. So now we have to calculate the capacitance of this capacitor. So let the area of each plate is A, distance between them is D, electric field which is existing between the two plates is sigma upon epsilon naught. Then the charge stored by this system is sigma into A, because sigma is the charge density into area is the plates, area of plates. Sigma into A is the total charge stored by the capacitor, and potential difference, which is nothing but electric field intensity multiplied by separation distance. In electric field industries, sigma upon epsilon naught, and distance is d. Distance between the plates is d. So potential is also there. So electric capacitance comes out to be Q upon B, ratio of Q up to V. Now, this is nothing but sigma into A, the value, V, sigma upon epsilon naught into D, this value. So sigma cancels out and this epsilon goes in the numerator. So epsilon naught A upon D. The capacitance of this capacitor is epsilon naught A upon D. In air, if there is air between the two sheets, if there is some dielectric medium between these two sheets having the same distance d, area A, charge density sigma minus sigma, and here it is filled with some dielectric of dielectric constant K. Dielectric constant K. Then what will change? Here the potential will change. Charge will remain the same, sigma A. The potential will become sigma upon epsilon naught into K. Therefore, the capacitance in the medium, with the medium, dielectric medium, will be sigma A upon sigma epsilon naught K into D. This is D. So, sigma will cancel out and this is nothing but epsilon naught Ka upon D. So from here we can conclude that C medium is epsilon naught Ka upon D, air is epsilon naught A upon D. So the ratio of capacitance of the parallel plate capacitor in medium to air is nothing but K, that is the dielectric constant. So we define the dielectric constant by this way: a ratio of the capacitance of parallel plate capacitor or a capacitor in that medium to the capacitance in air. Now here is one assignment: find dimension of capacitance, electrical capacitance. This is the assignment for you.